On 19 November 2024, the air quality index in Delhi crossed 500, which was classified as severe by Central Pollution Control Board. The schools were closed, traffic movements were restricted, construction activities were stopped, and even public health warnings were issued by the authorities. But how was that level of severity determined? How do we actually measure pollution in real time? And how do we know when it's dangerous? The answer lies in environmental monitoring. We use a network of monitoring stations equipped with instruments that track pollutants like PM10, PM2.5, nitrogen dioxide, sulfur dioxide, ozone, and carbon monoxide. These values are then analyzed using frameworks like India's National Ambient Air Quality Standard and converted into AQI through a standardized index system. Therefore, environmental monitoring is essential not just to detect pollution, but to help us make better decisions to develop policies and ultimately protect human and environmental health. Welcome to this course on environmental monitoring and instrumentation. I am Dr. Prasenjit, and I will be guiding you through a 15-week journey where we will explore both the foundational concept and real-world aspects of environmental monitoring. This course includes industrial collaboration, giving you insights into real-world practices and how monitoring is implemented in the field. This course carries 4 academic credits and attains NCRF Level 7. The main objectives of this course are to help the students learn about the basic ideas and methods used in environmental monitoring, to understand how to collect and test samples of air, water, and soil using common scientific tools, to get a clear idea of how environmental monitoring systems work and how measurements and tests are done to check environmental quality, to introduce new tools like sensors, IoT devices, and remote sensing that makes the environmental monitoring easier and more effective. The course is designed for a wide range of learners, including postgraduates in environmental science, engineering, and art sciences, as well as researchers, environmental consultants, professionals in regulatory bodies, and the aspirants of civil service and other competitive exams. This course opens up a wide range of career opportunities in both public and private sectors. The students can work in environmental consulting firms, pollution control boards, research organizations, and industries that require environmental compliance and monitoring. It also provides a strong foundation for roles like environmental analyst, monitoring technician, laboratory specialist, sustainability officer, and even research associates in air, water, and soil quality assessment. The course is structured into 40 modules where we will cover topics like types and classifications of environmental monitoring, how environmental instruments work, from basic sensors to advanced devices, frameworks for monitoring air and water quality, remote sensing and GIS, meteorological monitoring, the principles of quality assurance and data integrity, national and international policy frameworks, including NACs, BIS norms, and WHO guidelines. You will also learn how monitoring data is used in environmental impact assessments and how it connects to global initiatives such as Sustainable Development Goals, especially SDG 3 on health, SDG 6 on clean water, SDG 11 on sustainable cities, SDG 13 on climate action, SDG 14 on life below water, and SDG 15 on life on land. By the end of this course, you will be able to explain the principles and objectives of environmental monitoring and pollution assessment, design and implement sampling strategies for air, water, and soil environment, assess industrial emissions and pollution control measures using standard protocols, operate, interpret, and critically evaluate monitoring data, apply quality assurance, quality control techniques, and generate environmental reports aligned with regulatory guidelines. Integrate remote sensing and GIS tools in large-scale environmental monitoring systems, analyze and interpret real-world case studies to understand practical challenges, regulatory compliance issues, and innovative solutions in environmental monitoring. Thank you for your interest in this course. We look forward to your registration and active participation as we explore the science of monitoring the world around us.